Hey guys, we're gonna do a little bit of 7.2 follow-up. And again, remember in your book, this might be 7.1. But I wanted to do a couple practice problems that I found in your book or on the internet. I can't remember which. Um, sorry about that. So first one says, Consumer Reports Research Center survey of 427 women showed that 29% of them purchase online books. So the question asks, find a 95% confidence interval of all women who purchase online books. So again, this is what you need to understand about confidence intervals. What they're trying to do is they are trying to make a prediction about the population based on the sample. So they're trying to extend your knowledge. So you have a sample, but then what can that tell you about the population? So we're going to build a 95% confidence interval. We're going to first do it by hand. That'll be part A. So let's do this by hand. And we know we need this formula, p hat plus the error, right? Oops, it's pretty ugly. P hat plus the error. Okay. Well, did they already tell us p hat? They already told us that 29% of them purchase online textbooks. So we already know that p hat equals 0.29, and we need to find the error. Well, we know that we can just do 0.29 plus or minus z alpha over 2. You know what, maybe I better write out the formula since we're kind of new to this. So let me do this. This would become p hat plus or minus z alpha over 2 times the square root of p hat times q hat divided by n. Okay, so that's what we're going to do. We're going to do p hat, which is 0.29 plus or minus. Now remember, how do we find z alpha over 2? Well, in this case, they told us that it's a 95% confidence interval. Okay, so we remember from our notes, if we go back to the notes, if we go back to our notes from chapter 7, we remember way up here, we remember our critical values for z alpha over 2 when we're doing 95 is 1.96. Okay, so I'm going to come over here and I'm going to go back to my 7.2 practice, and we're going to use 1.96. So 1.96 times the square root of p hat, which is 0.29. But if p hat is 0.29, then q hat has to be 0.71, right? Because that's the leftovers. And then we have 427. Okay. Yeah, it's pretty ugly. So what do we get for our answer? So we get 0.29 plus or minus, and I'm going to do second function square root 0.29 times 0.71 divided by 427. And I get 0.029 or 0.02195. So 1.96 times we can just do this, 0.02199. Let's round off to 0. And let's multiply that times 1.96. So 0.0220 times 1.96. So we get 0.0431-ish. Okay. So I'm going to say we have 0.29 plus or minus 0.0431. I'm going to have to move this over a little bit. So use calc over here. Use the calculator over there. Okay. So now this means that our confidence interval is, I'm just going to simply do 0.29 minus 0.0431, and I get 0.2469, comma, 0.29 0.29 plus 0.0431. And I get 0.3331. And then we would, I didn't leave myself enough room, but we would then follow this up with, we would say, I am 95% confident that the true population proportion for all women who purchase books online is between 0.2469 and 0.331, or 24% and 33%. Okay, so this is our correct answer. And then normally in the homework, they're going to ask you to follow that up with your statement. Okay, so maybe if I have room over here, I'll do it for the calculator. So now we're going to do the calculator. Remember, we're going to go to stat, test. We're going to go down on mine, it's A, so it says 1 prop Z int, okay? And then I'm going to hit enter. Now the thing is, it asks us for X, okay? It asks us for X. So we have a problem here because they told us 29% of 427. They didn't actually tell us how many women purchase online books. So we're going to have to do a little calculation first. We're going to do 0.29 times 427 women to see how many actually did. And I get 123. So X equals approximately 123.83. So I'm going to call that 124. Okay, so 124 women purchase online books from this 427. Okay. So, and you could round down as well. I don't think it'll matter too much, but I'm going to go with 124. So we're going to go stat test 1 prop Z int. And now it says 124. How many women were in the total survey? 427. And we want a 0.95 confidence level. So when we do it this way, so we're going to do 124, comma, 427, comma, 0.95. And we get confidence interval of 0.2473, comma, 0.3334. Well, I guess it's 35 if you round off. Okay, so this would be the answer from the calculator. And once again, you see that they're really darn close to the same. They're both about within what, like 6/10,000ths of each other or something like that, or 4/10,000ths of each other. So it's pretty darn close to the same percent. And if you were to call one of them, you'd say the first one was 24.7% and the other one's 24.7%. So we would say, hopefully I have room here. I am 95, or we could say we are 95% confident that the population proportion of women who purchase books online is between, and then I would just say, and you could even round it, you could say 24.7% and 33.4% if you wanted to round off. Okay, so this is all necessary. This is part of your answer. This is how you explain what you just found. And you do this because you really don't want to kind of just feel like you're hitting enter on the calculator. You want to know what you just found. Now, you can see that this could be used, so with all the new technology that's coming out, people could use this information and they could say, wait a minute, 24 to 33% of women buy books online. Why are we as a company not selling more books online? We only have 5% of our sales for books online. So that means we need to step up. There's a much larger population out there we can reach. Or a much larger percentage of the population that we can reach. So we need to start spending more money on promoting our online services. So this is how companies can use statistics to figure out where they need to improve their business on. People do this all the time. Companies do this all the time. Okay, hopefully you guys can see how this might help. Okay, let me separate this a little. Sorry, you guys, Okay. So now we have this next one. Okay, so, and again, you guys, if you want to try this one right now on your own without my help, pause the video, try it, and then come back to the video, and let's see what happens. Okay, so it says in a Harris poll, it's just a type of poll, of 514 human resource professionals, 90% said that the appearance of a job applicant is most important for a good first impression. Okay, so that's why they always tell you to wear like a tie or a dress shirt or something, or, you know, a blouse, or, you know, something nice. Because first impressions make a big difference in an interview. And according to this, it says they interviewed 514 human resource professionals. 90% of them said that the appearance of a job applicant is the most important thing for a first good impression. So here's the thing. We instantly know P hat is worth 0.9. But if we know P hat, do we instantly know Q hat? Yes, Q hat is 0.1, right? So we have this information. We know N is worth 514, okay? So we know everything we know, and we know our confidence level is 0.99, okay? So what we're gonna do is we're gonna use this with our formula, P hat plus or minus the error, okay? So what we're gonna do is we are going to then say 0.9 plus or minus Z alpha over 2. Remember our formula to find the error, Z alpha over 2. For 99% confidence level, we're going to, or a 99% confidence interval, we're going to use 2.576. And again, I got this from the table that I gave you guys for 90, 95, and 99. And we're going to multiply this times the square root of 0.9 times 0.1, all divided by, maybe I should use parentheses instead of that. So 0.9, and then divided by the square root of 514. Okay, so we have 0.9 plus or minus, and let's just enter this in our calculator, 2.576, 2.576, parentheses, second function square root, 0.9 times 0.1 divided by 514. And I get 0.0341 if you round off to 4 decimal places, okay? So then I now know, now I'm gonna write it a different way because I think in the book sometimes they do this. I'm gonna put the P right here. This is not P hat, this is the population proportion, right? And they're gonna say, oops, let's do less than or equal to. And again, this is how the book might write it sometimes, so I just want to prepare you guys for this. They're going to do 0.9 minus 0.0341, and they're going to do 0.9 plus 0.0341. So let's do that. 0.9 minus 0.0341. I get 0.8659 is less than or equal to P is less than or equal to, well, this will be 0.9341. Okay, so then we have our confidence interval. This is sometimes how they'll write it. And notice this is not P hat. Remember, we're trying to make a prediction about the population. We're trying to say, based on this sample, this is how the population proportion will behave. So this is our population proportion, or our percentage, if that helps you think about it better. This right here is our sample proportion, okay? So just keep in mind, this and this, the P hat and P are two different things. One is for the sample, one is for the population proportion, okay? So again, and the other way we would write this is we would write it as 0.8659, comma 0.9341. Okay, so we're saying that P is somewhere in between. Well, actually, let me get rid of the equals too. I don't think we normally put equals. Yeah. So we're saying that the population proportion is somewhere in between these values. Okay. And again, this is in general the way that the book may write some stuff. And I just wanted you guys to be prepared. So when you see it like that, it doesn't freak you out at all. You're just kind of comfortable with it. Yeah, do strictly less than. So these are both correct. Both of these would be correct. It just depends on how the book asks you to write it, or what your preference is. They're both the correct answer though. Okay. Now we could then follow this up and say, I am 99% confident that the true population proportion of, and then we read the question. What was the question? That appearance of job applicants is the most important for a good first impression. Population proportion of, oops, I wrote out twice, of human resource professionals feel that, or state, feel that, let me make sure I'm not messing this up. Let me read the question. Believe, let's say believe. You could have said feel that. Believe that appearance of job applicants is most. So I am 99% confident that the true population of HR professionals who believe that appearance of job applicants is most important is between, and then you could state 0.8659 and 0.9341, and you could convert them to percents if you want as well. Okay, now again, let's just practice using our calculator. So let's use our calculator over here, part B. Oops, that's too big. So part B, calculator. So we would just do one prop Z int, okay? Now, they told us 90%, so once again, we're gonna have to come up with 90%, so 0.9 times 514, because we need to come up with how many. So I'm gonna use X equals 0.9 times 514, okay? And I get 462.6, so let's use 463. Okay. I guess we could use 462 as well. Maybe in this case, let me think, is it better? Well, I'm not gonna debate over it. It's gonna be such a small percentage. Rounding probably will take care of it, but actually in this case, we might wanna round down to 462 so we're not overestimating. Yeah, let's try 462 for this one and see if it makes a huge difference. I don't believe so. So we're gonna do stat test one prop Z int, and I'm gonna use 462 out of 514, and I'm gonna use 0.99. So I'm gonna use 462, comma, 514, comma, 0.99. And we're going to get a confidence interval. We get 0.8646, and over here we get 0.9331 if we round off. 8646, yeah. 8659. So that's a little bit different than what we got. Let me see if it makes a difference. Let's go stat. Let's use 463, see if it makes a huge difference. 0.8668, no, it wouldn't. So, and again, there's always some rounding error in here because we're using 3 decimals for the Z-score, and there's some other rounding that I'm doing in each of these problems. So there's always bound to be a little bit off, but this is normally how you can tell that you're off by a little bit, or if I was grading your exam and I told you to do it by hand, I could normally tell if you used the calculator because you'd be off from my answer by a small margin. But in this case, if you're doing the exam online, you may not, you probably will be able to use the calculator in all instances. Okay, so I just wanted to show you guys a little bit of this practice work, okay, how you could see the problems presented. So now let's go back to chapter 7. Oops, let's go back to chapter 7. Okay, and let's scroll down to where we left off. I think we left off here. Okay. All right, so let me get situated on the new topic. So in chapter 7, we're going to be talking in 7.3, which I believe in your book may be 7.2. We're going to be talking about estimating population mean. So if you read above, it says, remember, we know nothing about the population. So both population mean and population standard deviation are unknown. Being able to use z-scores for problems involving the sample mean requires knowing the population standard deviation. And think about that. In general, with z-scores, you need to know the standard deviation. You need to know the standard deviation if you're working with the mean. And z-scores. So it says, so we will need to use distribution. It's often referred to as student's t distribution because the standard deviation of the pop is unknown. So this is what you use in general if they're talking about the mean, okay, and they want to know a confidence interval, okay. So below it says the definition when the standard deviation of a statistic is estimated from the sample, the result is called the standard error of the statistic. The standard error of the sample mean, x bar, is given by S divided by the square root of n. This is often just referred to as SE or standard error, okay? So in this problem here, if we wanted to just find the standard error, okay, it says the standard error is equal to the standard deviation divided by the square root of n. So it says the travel time to work for a sample of 20 employed adults in New York State has a mean of 31.25 minutes and a standard deviation of 21.88. What is the standard error of the mean? So they're telling you the mean, and they want to know the standard error. Well, they're going to use 21.88, okay, divided by the square root of 20. So all I'm doing is I'm just using this formula right here. Should be very nice and straightforward for you guys, okay? And when we plug this in our calculator, I'm just going to say we get 4.89, I believe. Let's do 21.88 divided by second function square root of 20, and I get 4.8925. So let's just say 4.89, okay? So this is our standard error, no big deal. Okay. Now it says in yellow right here, if you guys read, it says if we do not know the standard deviation of the population, we can no longer use normal distribution and thus can no longer use z-tables. So this is a big change for us. Everything we've been using has been using z-tables or the calculator with normal distribution. So even though you're not using the table, the calculator in a way is. It says we must use a new distribution called the t distribution. We will replace the critical value with a t-score. So you remember before how we did z alpha over 2? Now we're going to move on to t alpha over 2, okay? And for confidence intervals, we're always talking about two tails separating the left and the right regions, okay? So it'll always be for confidence intervals alpha over 2, okay? In hypothesis testing in chapter 8, it will be always two tails. Sometimes it'll be one tail, and we'll get to that in chapter 8. Okay, so here's the formula that you need to know. You need to know how to use. Some people just try to memorize it, but not know when to use it. We're going to definitely try to go through when to use this versus when to use z, okay? So it says you do x bar minus mu divided by the standard error, okay? And it says it has n minus 1 degrees of freedom. Now, degrees of freedom is kind of a difficult thing to explain. So I heard one guy or one instructor say this once, and hopefully this makes sense to you, or I read this online. It says degrees of freedom is basically if you have 7 days of the week, okay, you want to do something 7 days of the week. Well, one of those days of the week, you have to spend planning what to do on the other 6. So if you have 7 days of the week, then you have 6 degrees of freedom because one of those days has to be used to plan what to do the other 6 days, okay? But basically what it's saying is if you have one parameter, so let's say you have 100 things that could be anything, they could vary, okay? And there's one thing that ties them all together, okay? So the degrees of freedom is always one less than the total number of things if you're using one parameter, okay? So like, for example, in this problem, we're talking about mean. So mean is gonna relate everything together, okay? So I guess we could do it like this. Maybe this calculation, I haven't explained it this way before, so bear with me. Let me try this. So suppose that we know that the mean is equal to 5, okay? Or let's say 4, okay? And I have, this first value, let's say x1 is equal to 2, x3 is equal to 5, and x4, oh, oops, why am I writing like that? x2, x3, okay, and x4, okay, and then this is 6, let's say. And then this one, we don't know. So we know that we're going to do 2 plus 5 plus 6 plus x4, and we're going to divide that by 4, and that has to equal 4, right? So what I'm going to do is I'm going to solve, okay? So I'm going to say this is what, 13 plus x4, and again, I'm just randomly picking x4, it could have been x1, is equal to 4. Now I'm going to multiply both sides by 4 to cancel. And you guys aren't going to have to do this. I'm just trying to find a better way to explain it than, 6 days a week and 7 days a week. Oops, what am I doing? This doesn't cancel. This is just plain old 4 times 4 over 1. Okay, so then this would be 13 plus x to the 4th equals 16. So then we subtract 13, oops, subtract 13, so then x4 equals 3. So here's the thing, the x1, x2, and x3 could have been anything. You can do anything, but to make the mean become 4, x4 had to be 3. So basically what happens is when you're talking about degrees of freedom and you have variables that could mean anything, all of them could mean anything, but if you're talking about mean or standard deviation or something, there has to be one of them that is, I guess, fixed. One of them that has to be something in particular to make the values relate to the mean. So that's what I was trying to do over here. I don't really know if this made a lot of sense to you guys, but basically what we're doing is we're saying one of the values has to mean something, has to be something particular, okay? So the long and short of it is however many things you're dealing with in your sample, the degrees of freedom is always one less, okay? Because one of those things is going to account for that parameter, okay? So if you're doing 2 things, then you might have to do degrees of freedom minus 2 if you're dealing with 2 parameters. So in this case, degrees of freedom, don't stress too much about it. It's just how we can look things up on the table. But whatever your sample is, whatever your n is, the degrees of freedom is always one less, okay? Attributes of t-distribution, I'll just kind of show you real quick. So let's suppose that this is normal. Oops. Let's suppose that this is normal. Okay, so that's normal distribution. Here's t-distribution. And I'm over exaggerating because I can't draw too well. So t-distribution has more value in the tails, more area in the tails. Still not a massive amount, but it's more than normal distribution, okay? And you guys can go through and read that. Degrees of freedom is n-1, symmetric, centered at 0. That's good, right? Because it's, oops, what happened there? It still is centered at 0, just like the normal distribution, okay? Total area under the curve is 100% or 1, just like before, and approaches a standard normal distribution when the degrees of freedom are large. So if you get a massive, like you have a sample of 10,000, it's basically going to become normal distribution, which is, nice and preferable to anything. So here we're talking about confidence intervals for mu. Okay, so again, as always, it has to be a random sample. And the population is normally distributed or n is greater than 30. Okay, so it says to find the margin of error. So these are the 2 formulas I'm looking at right here. I'm kind of jumping ahead to find the margin of error. These are my 2 formulas that I'm looking at. Okay, so we're going to do everything the same, but we're now working with, instead of p hat, which was our population estimate, or our point estimate for the population proportion, we're now going to be working with x bar, which is a mean. We still have to find the error, but the error is a little bit easier to find. It's just t alpha over 2, right? It's just t alpha over 2 times the standard deviation divided by the square root of n. So let's take a look at a problem. I've been doing a lot of talking. Let's do some writing. So it says, suppose that a random survey of 10 teenagers found that the average amount of time they spend on the internet each day is 3.2 hours with a sample standard deviation of 7.8 or 0.78 hours. What assumptions must be made in order for the confidence interval to be valid? So here's once again where I was kind of telling you about kind of how statistics, sometimes things aren't stated, but if you want to move forward, you kind of have to go with it. Well, the first assumption is that it has to be random variable. It has to be random. Okay, we're assuming it is, otherwise it wouldn't make sense to talk about the problem, right? And the second thing is it's normally distributed, or n is greater than 30. Okay, so we have to assume these things. In this case, we have to assume that it's normally distributed to move on. So a lot of times, that's what I mean. Like, even though it didn't say, if we want to do this problem, we have to assume it's normally distributed. Okay, so it says, suppose a random sample 10 TNC. It doesn't say it in there anywhere, right? So we're going to assume this to be true. Now, we do know some facts. We do know that n equals 10. We do know that x bar is equal to 3.2. And we do know that the standard error, did they tell us, with a standard deviation of with a sample error, standard deviation of 0.78. Well, we know standard deviation, let's say that. We know standard deviation, S is equal to 0.78. Okay. Sample standard deviation 0.78. Yep. So it says, what are the point estimate and the standard error of the population average amount of time teenagers spend on the internet each day? So we know that the point estimate, x bar, is going to equal 3.2. Now, again, that's not the population, but that's for our sample of 10. That's what it is. Okay. Our x bar. That's our estimate for mu. We don't know mu, but we want to try to talk about it. We want to try to build a window around it, okay? And the standard error is going to be, let's see here, 0.78 divided by the square root of 10. So I get about 0.247 when we put this in our calculator. Let me just double check that. 0.78 divided by square root of 10. Yeah, I get 0.246657. So let's just say 0.247 for ease. And now it says, assuming necessary conditions are met, calculate a 98% confidence interval for the average amount of time teenagers spend on the internet each day. Okay, so we have some work to do. So it says up here, our formula to find the error, to find the margin of error. Remember, we're going to be doing this formula. X bar is equal, X bar minus the error and X bar plus the error. That's how we're going to build our confidence interval. So I'm going to build this one first by hand. So we're going to use this formula, X bar, which is 3.2 plus or minus the error. Now the error is T alpha over 2 times, so T alpha over 2, sorry, my phone rang, T alpha over 2 times, let's see here, what do we have? 0.78 and 10. So I'm going to do but we know 0.247. We already found it up here, right? We already found our standard error right here. So the only question is, what the heck is T alpha over 2? Okay, so I'm going to take you guys to our table first, okay, because some calculators do not have some of this T stuff on their calculator. So some scientific or graphing calculators don't have this. So how many people were in our sample? Well, there were 10 people, but remember, I told you guys that degrees of freedom is always one smaller. So what we're going to do is we're going to focus here at 9. Okay, so we're here at 9, degrees of freedom of 9. And now we're looking for how much area is in the two tails. Well, if we're doing a 98% confidence interval, that means there is 2% of the area left over in the two tails. Okay, so it says area in two tails 0.02. So what you guys need to do is you need to line up that 0.02 with the 9 degrees of freedom. And I get 2.821. Let's see here. Yeah, 2.821. Or if you wanted to say, well, if there's two tails and there's 2%, then each tail has 1%. You could also say area in one tail is 0.01. You get the same answer. So I'm going to go over here. I'm going to go over here. And I'm going to do 3.2 plus or minus 2.821 times 0.247. Okay, and this should give me my interval. So I'm going to do 3.2 minus 2.821 times 0.247, and I get 2.503. And then I also am going to do 3.2 plus 2.821 times 0.247. And I get 3.89. Let's say 7, because the other one was, we did 3.897. Okay. So that would be my confidence interval for the t distribution. So we're going to write it right here. 2.503, comma 3.897. So now it says interpret. So interpret your confidence interval. So we say we are, or I am, 98% confident. True, or the population mean, amount of time internet is between, oops, happened there. Sorry about that, guys, I hit the wrong button. Between 2.503 and, I guess I could do it like this, and 3.897. Okay. Now, again, if your calculator has this, you read in yellow that we could have done this on the calculator. It says stat test t interval. So let's try this t interval. And let's see what they ask for. So I'm going to go stat test t interval. On mine, that's number 8. So it says x bar. Do we know x bar? Yes, we do. It's 3.2. It asked me for S of X, the standard deviation of X. We know that. That would be 0.78. How many people were in the survey? 10. And level of confidence, 0.98. So it gives me, it takes a little bit longer. It gives me 3.2, comma, 0.78, comma, 0.98. Stat. So it asked me for that. Oh, and it asked me for n. Sorry about that. It asked me for n is 10, and then it does 0.98. So it gave me 2.501, 04. And 3.8959. going to be a good rounding. So 3.896. So that would be the calculator answer. And as you can see, it's really darn close to our other answer. So you can do it both ways. I just wanted to show you by hand using the table, but you could also use your calculator as well. Okay, so let's move on. Let's see if we're going to finish this today. We'll try to finish this next page. Okay, so it says the IRS is investigating the income obtained from tips in various types of services. In a small pilot study at a gourmet restaurant, the agents randomly selected 30 charge card receipts and computed the average tip to be $11.20 with a standard deviation of $1.79, basically, at $1.80. A confidence interval for the average tip is given by patrons of this restaurant of 10.79, 7696, and 11.6304. Assumed charge card receipt amounts have normal distribution. Okay, so they kind of switch gears on us real quick. This is kind of going way back to previously when I was talking to you guys about how if you're given a confidence interval, you can still find stuff out. Now it says, let's see here. It says the margin of error for the confidence interval is what? Okay. So we know that way back up here, you guys, I'm sorry, the notes kind of jumped around right there. I wasn't even ready for that. So it says right here, the margin of error can be found by doing this. Okay, so upper limit minus lower limit divided by 2. So we're going to go way back here. I knew it was in the notes. I just didn't realize it kind of jumped. Okay, so we're going to do the confidence interval of 11.6304 minus 10.7696, and we're going to divide that by 2. And let's see what we get. And this is our error. Okay, error margin of error. So we're going to do 11.6304. 11.6304 minus 10.7696. Then we're going to divide it by 2, and I get 0.4304, which would be this guy right here. So we get 0.4304. We know that it's C. So that's a homework question and a test question you might see. It's pretty straightforward. Okay, and it says based on this, find the critical value and the confidence level. Okay, so let's see here. Let's use E is equal. Now let's see what they're talking about. The average tip given by a patron. So now think about this. They're talking about the average. Isn't that the mean? So are we working with Z, or are we more than likely working with T? Sometimes you can work with Z with the mean, but you would have to know the standard deviation of the population, which in general you will never know. So we're going to say E is equal to T alpha over 2 times S over the square root of N. That's how we find error, right? Well, we just found the error to be 0.4304, so I'm going to type that in. And that's equal to T alpha over 2 times. Now, do we know the standard deviation of this problem? We know the standard deviation is what? With a standard deviation of 1.798, it's right here. So I'm going to do 1.798, and I'm going to divide it by the square root of how many? 30 charge card receipts. Okay. So basically, hopefully you guys understand how to solve for T alpha. We're just going to multiply this times the square root of 30 over 1.798. This will cancel this. This will cancel this. This will be 1, 1, 1, 1. But whatever you do to one side, you got to do to the other. So I'm going to take square root of 30 over here, and I'm going to do 1.798 over here. And we just enter that in our calculator, and that should give us our T alpha over 2. So I'm going to do second function square root of 30, enter, divided by 1.798, enter. Then I'm going to multiply that by 0.4304, enter, and I get T alpha over 2 has to be 1.311, let's say, 311, yeah. Okay, so my critical value is T equals 1.311. Okay. Now we need to find our confidence level. Well, that means I'm going to have to go back to my t distribution. Okay, let's see if we can do this. Okay. So we got 1.311. Now we know that we're dealing with degrees of freedom of how much? What's our degree of freedom? Well, our degree of freedom is 29 because there were 30 receipts. So we're going to be dealing with 29. Okay, and if we look way over here on the right-hand column of 29, okay, way over here on the right-hand column of 29, right, we have 1.311. What a coincidence. So then we're going to scroll up and see what is the alpha, what is the confidence level. Well, they said there's area in two tails for that category of 20%. Well, if alpha is 20%, then what's the confidence level? It's the leftovers, it's 80%. So we're going to come back over here and we're going to type in 80% confident. And that would be our other answer. Okay. So this is just a way you can use those formulas from previously. If you're given a confidence interval, you can use it to back solve for other things. Okay. Now let's look at this one. So it says consumer reports randomly tested 14 brands of vanilla yogurt. Assume the population of vanilla yogurt calories is normally distributed. The data below represents the number of calories per serving. So an important thing they told us is normally distributed. So we're good. And it says, what are we going to end up doing here? It says create a 95% confidence interval for the parameter of interest and interpret the interval. Okay, so it says consumer reports randomly tested 14 brands of vanilla. Assume the population of vanilla yogurt calories is normally distributed. The data below represents the numbers per serving. Check the requirements for creating a confidence interval for the mean when standard deviation of the population, sigma, is unknown. So two things we have to take from this. A lot of students have a hard time identifying when to use t-distribution, okay? In general, not every single time, but I'd say 99% of the time, just as a made up statistic, 99% of the time when you're talking about mean, you're going to use t-distribution, okay? But 100% of the time when you're talking about mean, right here, and sigma is unknown, the population, you have to use t-distribution. So that's the deciding factor. That tells you when to use t-distribution, okay? So we know that it is random and it's normal. So 1, random, check, and 2, it's normally distributed or n is greater than 30. Well, they already told us it's normally distributed, so we're good, check, check. It says create a 95% confidence interval for the parameter of interest and interpret your interval. So I'm going to test using my calculator since they didn't leave me very much room here. I'm going to do t interval. And then remember, t interval requires us to know certain things. T interval, if you go in your calculator, you're going to see that you go stat interval. And it requires us to know X bar. Well, there's another way to do it. You can actually go and use some of the old stuff that we used. So what I'm going to do first is I'm going to go to stat and edit. Okay. So first, maybe I'll write it over here in green. First, enter values into a list. So let's write this smaller. First, enter values into a list using stat edit. A little too fun. Using stat edit on your calculator. So I'm going to go stat edit and I'm going to create my list and I'm going to use the values they gave me 160, 200. So I'm going to build my list one. Remember using list one when we had to do mean and standard deviation? We're going to enter these in. So 160, 200, 220, 230, 120, 180, 140, 130. Make sure you enter them all in right. 170, 190, 80, 120, 100, and 170. So it says that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And my list has 14. So I think I'm good. Okay, so I feel like I entered it in pretty good. So now I'm going to get out of here. I'm going to go second quit and get out. Now let's go back into T interval. So now you see how T interval asks us for if we want to use data or stats. So in the past, we've just been saying stats because we were already given X bar or whatever and the standard deviation. Well, I'm going to use data because they gave me the data and I'm going to enter it into my list one. So it says use list one. Frequency should be 1 or blank. And then what confidence level? We want 95. So I'm going to do 0.95. So I'm going to do T interval list one. You know what? You can just do T interval list one, comma 95%. Okay. Because it depends on the calculator you have. So I'm going to just go with that. And it's going to spit out my interval. So I get an interval of 132.02, comma 183.70. Okay. So they told me my confidence interval just by using the calculator, and I didn't even have to calculate anything. Now, if I wanted, I could have gone to stat and calc, single variable stats, and I could have found my standard deviation, which is 44.75. I could have found my X bar by doing 157.86. So I could have used these values to plug in, but since they gave me the list, I just used my list, okay? So notice up here, it's slightly different than how I entered it in the calculator here with T interval. Because in this case, in this particular problem right here, I knew all of these things. I did not know the data, so I used the statistics. In this problem, I do know the data, so I just used the data instead of using the statistics, okay? So now it says, a diet guide claims that you will get 120 calories from a serving of vanilla yogurt. Does the confidence interval support this claim? Explain in a full sentence. So now think about what this confidence interval is saying. The confidence interval is saying that check the requirements for creating a confidence interval for the mean, okay, found in vanilla yogurt, 14 grams of calories. So according to our confidence interval, again, you guys, according to this right here says that the mean of all yogurt, of vanilla yogurt, is somewhere between 132 and 183 calories. We don't know for sure what it is, but we are 95% confident, right? 95% confident that the mean is somewhere in there. So I'm pretty sure that it's in there. So then a diet claims that you will get 120 calories from a serving of vanilla yogurt. Does this sound right according to our confidence interval? We're going to say no. No, this does not sound right. No, 120 is under our lower bound for the population of calories. It's not even in, 120 is not even in our confidence interval. So based on that, I'm going to say that this diet doesn't sound very likely because 120 is not even in it. Now, what if the diet had said, instead of 120, it had said 140? Would that make sense? Would that be reasonable? The answer is yes, because is 140 in our window that we're allowing the calories to be? Yeah, 140 is in that window. So we would say, yeah, that makes sense. We're not for sure, but that makes sense. That's a reasonable assumption that 140 calories from a serving of vanilla yogurt. Because again, you guys, it's very important you understand. We don't know for sure what it is either. We don't know the mean amount of calories for the population either. But what we know is that we're 95% confident it's somewhere in our window of 132 to 183. Okay, does that make sense to everybody, I hope? All right, so it says down here in red, it says if you know the population standard deviation sigma, you would use the interval, but this is unlikely. And that's because in general, you do not know the standard deviation of the population, okay? In general, you just don't. So if that ever happens where a problem says, and hint, you do know the standard deviation of the population, well, then you can still use your z-scores, okay? Now, here's a way that we can, I believe this will be the last page I do today. Here's a way that we can work with standard deviation. So it says sample size calculations for means. Okay, so now we're switching from population proportion and the number that you need for that. So that was what we did kind of at the end of the last video. Now we're going to switch to sample size calculations to find good mean averages. Okay, so it says problem. In order to find out what t-score we need to use, we need a degree of freedom, which is n-1. However, the whole point is, you guys, that we're not going to know n. We're trying to find it. So how could you do it? So we don't know n because that is what we're trying to calculate. So we often use a prior sample standard deviation or a population standard deviation from another group and insert that for the standard deviation. So remember, again, I keep telling you guys, statistics is kind of a weird type of math. It's sometimes if you don't have the required stuff to do the problem, you do it anyway and just tell somebody, hey, I had to use this, okay? So it says many consumers pay careful attention to stated nutritional contents on packaged foods when making purchases. It is therefore important that the information on packages be accurate. In a random sample of lean pocket frozen dinners, the sample mean was 249.3 with a standard deviation of 12.38. It says how many dinners would be needed in order to estimate the average calorie content within 8 calories with 99% confidence. So we're going to use this formula right here to calculate n. They want to know how many lean pockets we're going to need to get, right? So we're going to say n equals, now we're going to use z alpha over 2. So let me see here, it says 99% confident. So we know that 99% confident from our old z critical value, not our t critical value, but from our old z critical value, we remember it to be 2.575, I believe. Let me scroll up. Sorry guys, it's going to mess with your eyes a little bit. Let's just go way up here. Let's just see if we're doing this right. 2.576, sorry about that. So 2.576, so I'm still using that z value. And that's because the formula told me that we're going to have to use z because we can't use t because we don't know degrees of freedom. And then we're going to multiply that by the standard deviation. Okay, and it says in a random sample of lean pocket frozen dinners, the sample mean was 249 with a standard deviation of 12.38. Now I want you guys to notice something right here. That says that we're supposed to use the population standard deviation, but we don't know it. We don't know the population standard deviation. Well, what do we know? We do know the sample standard deviation. So we're just going to use that anyway, even though it's not exactly what we want. So we're going to use 12.38. And again, that's kind of the rub on statistics. We don't actually have the right value, but it says right here, we often use a prior sample standard deviation or a population standard deviation from another group. So we're going to say, well, I guess this is a prior sample standard deviation. So let's plug that in right there. And then what's the error? It says within 8 calories. So we're going to divide this by 8, and then we're going to square the whole thing. So when we plug this in our calculator, we get 2.576 times 12.38 divided by 8. And then we're going to square that. And I get 15.891, but that's going to be 16. We're going to say that's 16. So it says when calculation is not a whole number, round to the next whole number. So even if this was 15.2, we would have still rounded to 16. So if it's 15.2, 15.3, 15.4, we still round to 16. We round to the next whole number, okay, the next biggest one, because you always want to take more than you need to make sure that your sample's okay. All right, so let's try this last one on this page. It says a machine is designed to produce a rubber gasket, or to produce rubber gaskets in a random sample of gaskets. The sample mean was 2.5 inches with a standard deviation of 0.01 inches. How many gaskets should be measured to be able to estimate the mean within 0.001 inches and a 90% level of confidence? So take a minute, write this down, write down n equals alpha over 2 times the standard deviation divided by the error. Now, once again, we are using a 90% confidence level, so hopefully you guys have memorized by now. That's 1.645 for z-scores times 0.01. Now, where am I getting the 0.01 from? Well, it said right here we have 0.01 inches standard deviation, and then we're going to divide that by an error within. They want to be within to estimate the mean within 0.001. So when you say within this amount, that's normally your error. Square that. And I believe you get approximately 270.603. So we're going to call that 271 gaskets. And up here, this was what, lean pockets? Okay, so that's basically a way that we can use z-scores to help us find the number that's needed when the sample standard deviation is known, but the population standard deviation is not known, and we're talking about the mean. Okay, so these are ways that we can work with the mean. Now again, we would love to use t-distribution, but the whole point in t-distribution is you need to know n so you can do degrees of freedom of n-1, but we're trying to find n, so you obviously don't know that ahead of time, so we can't use t. So these are formulas that we can use when working with the mean to find the number of samples needed to do this confidence level. I'm going to end that today, you guys. We will start 7.4 or in your homework, maybe 7.3 in the next video. All right. Thanks very much, guys. See you in class.